All right, welcome boys and girls. Eugene, Hughes Motorized. All right, so this here is going to be part one of a three-part series on beginning welding, okay? What I'd like to do is help you out to get a good welder for your home shop, some things to think about, what safety equipment you're going to need, what tools you're going to need in addition to the welder so you can weld safely and get the job done. I want to maybe save you the pain of buying something that you don't need and then have to go back and buy more stuff and spend a lot more money had you have bought the right stuff in the first place, okay? So I want to go over the intro to the welding process. I want to go over a good beginner welder that I suggest, and then we're going to follow it up. I'm going to link at the end of the video two videos, one to show you the basics and the beginning of stick welding and flux core welding, just enough to where you can start making some sparks, getting some metal to stick together, and you can go back and say, hey, I'm a welder, all right? So let's get going. Now, the people at Arc Captain sent me this welder right here. This is the MIG 145 Pro welder. This is a dual process, a multi-process welder. It will do both flux core welding and stick welding. This is an ideal welder for beginners. It's not a lot of money. You're looking at $145 to do both processes right out of the box, and then it's something you can grow with. If you decide you want to wet your feet and do TIG welding, with the lift TIG, you have to buy the torch, hose, bottle, and all that stuff. You can do lift TIG with this machine here as well. One other thing that makes it a great welder for a beginner, it's a 120 volt welder, okay? Another thing that makes it a good welder for beginners is it's not an overly complex welder. You've only got 3 buttons on here on the front for some settings, and you've got the dial that you dial in to adjust your amperage output on the machine, okay? Let's go over how the machine works here, okay? So you've got 110 volts coming into it, and then you're outputting DC current. You've got a positive and a negative terminal here on the front of the machine. You've got your cable that plugs into it. That outputs the current to either your working clamp or your stinger, or when you have the machine in the flux core mode, you're going to be outputting current out the wire here. You have a spool of wire that's fed out the cable to the torch that is energized negative polarity. Flux core welding is a DC electrode negative process as well. When you pull on the trigger, you've got this little wire here which is connected to your switch. Pull this, it then tells the machine to start feeding wire and of course energize the electrode at the same time, and you're making sparks. So you have the working clamp, which is going to be clamped onto a metal work surface or your workpiece, and you've got either the electrode in your flux core torch or the electrode in your stinger. In the stick welding process, and when the electrode is placed onto your workpiece, the arc is initiated. This is an arc welding process. You get the electrical arc, you're making sparks, lots of bright light, you're burning the electrode, and you're melting your workpiece, and the weld is deposited from the rod or the wire onto your workpiece as well. You're melting the electrode and the workpiece itself. You're depositing the filler metal onto your workpiece. The rods or the sticks are coated with the flux, with the exception of the end. That way you can put that into your stinger. It conducts electricity out the rod. You've got rod all the way to the end of it. The flux is burned up in the stick welding mode, and that then forms almost like a glass protective covering over the weld, shields the weld from contaminants in the air, and helps you get a good weld. In the flux core mode, the flux is inside of the wire that is fed, and that then as well covers the weld puddle and protects it from contaminants. Now we've got the controls of the machine here, and this particular one here, the MiG 145 Pro, is very easy to operate. You only have 3 selector buttons here, and you've got the dial here for selecting the output of the amperage that goes to your electrode. You have the mode switch, because this here has 3 modes. You've got the flux core, which is what it's selected right now. Press it again, we're in the stick welding mode. Press it again, and we're in the TIG mode. You need an optional TIG torch, bottles of gas, all that good stuff to do TIG welding. Let's go back into the flux core mode. Now, in flux core, you've got a couple of extra functions here. You've got this selector here where you can select the diameter of the wire. Right now we're running 0.035 wire, so I'm going to press it again. 0.040, 0.030. You would have to get a different size wire if you were to change those settings. So we have 0.035, that's what comes with the machine. We're going to leave it on 0.035. Now then, the FN switch here, we press that here, and that's where we can use the dial to select the thickness of the metal that we're welding here. This goes up to 0.21, which, hey, in my book, I just call it 1/4 of an inch. I can easily weld 1/4 of an inch with this machine here, and we can go way on down to 0.03 inch. Press it again, and then we're on the amperage setting. And with the flux core, we start at 40, and we can go all the way up to 145 on the flux core. The thicker the metal, the higher you want your setting to be here. On, like, let's say this 1/4 inch plate, I want to run it at about 125 amps. Would be fine. Now, in the stick welding mode, with a machine like this here, I would suggest you're going to run a 3/32 inch rod or a 1/8 inch rod. And the 1/8 inch is the bigger of the rods. The 3/32 inch rod, I would say run it at 70 to 90 amps would be fine. That's going to work for 3/16 of an inch thick material and lower. The 1/8 inch rod, you want to run this on 3/16 and above. And you want to, since it's a thicker diameter rod, it requires more heat. You want to run it at least, I'd say about 110 to 130 amps on the 1/8 inch. On some instances, you may want to go a little bit higher. You have to adapt your technique to your settings, adjust your settings to the material you're welding. This is an appliance that uses electricity, 120 volts in this case here, and it puts out a lot of current in order to effectively arc weld. And so you can get to some of the more thicker metals up to 1/4 of an inch with a machine like this here. It's going to draw a lot of current in. So that's not going to do so well on your standard 120 volt outlet. You might want to take a look and get your electrician buddy to put in a 30 amp circuit for you. At least a 20 amp circuit is going to be ideal. You plug this into the same circuit as, say, your deep freeze or washing machine, you're going to wind up tripping the breaker. So I want to save you that there. One thing you're going to want to think about in your shop is you need ventilation. This is an arc welder. Puts out a lot of heat, and as well with that, you're burning stuff out of the metal when you're doing it. You're burning the flux that's in the flux core, you're burning the flux that's on your welding rods, and that lets out some gas that you really don't want to be breathing, okay? So you're not going to want to do this in an enclosed area. You're going to want some good ventilation. Okay. Now in my little shop, I got a little bitty fan right here pushing air out my front door of my shop, and then I've got a big fan that blows a bunch of air in. So I've got a steady flow of air going out. That way I'm not breathing all that junk messing up my lungs. So you definitely want good ventilation. With flux core and stick welding, you can do it outside when it's still rather windy and not have any problems. That's something you can't do with a MIG welder. You get a brisk wind going and it's going to push away your welding gas and you're going to get a bad weld. So you get bonus points for having something like this available, okay? You can weld up to 1/4 of an inch with this machine here, the 145 amp machine here. It's application, and it's a lot of what you're going to need to do in order to effectively weld is work on your skills. You got to hone up your skills here. It isn't always just one setting works on this thickness of metal here. You can go outside those parameters with your skills. So I want to help you develop your skills, and we're going to do that in the following 2 videos after this here that I'm going to link up, okay? Now, this is an electric appliance. As such, I got to remind you, electricity kills, boys and girls. It can kill you, okay? You've got to be very careful, okay? So this is a DC welder, direct current. So you're putting current out, both the positive and the negative output of this machine here. You've got a working clamp, which you're going to clamp to your working surface or your work piece. And then you've got your welding wire or your stick electrode that comes out. When the positive meets the negative, you get sparks, you're doing welding. Well, there's a little problem with that for the human body. You do not want to get your body touching anything that the working clamp is connected to and touching the electrode. It can shock you. It can kill you, okay? There have been cases where I read somebody had a flux core machine, had the working clamp on their workpiece. They had wet gloves. They were touching the table, which was definitely connecting their body to the working clamp, and they went to lift their hood, and the welding wire was energized, touched them in the head, and killed them. Another thing you want to be careful about is having a welding stick in your electrode holder. You set it there, take your glove off, and you reach and you grab something on the table, and you accidentally touch the welding rod. You can shock yourself. So, safety. Got to think of that. Anytime your machine is turned on, you need to be vigilant about not completing the circuit between your electrode and the working clamp. So think. All right, let's go on. So with the welder, right out of the box, you're ready to do some flux core welding. And as well, you get you some welding electrodes, the sticks. You're ready to go here. But you're going to need some extra goodies here to get going here, okay? I recommend you get the best quality welding hood you can afford now. They start at $30 and they go up, but I'm going to tell you, at $30 you get what you pay for. I use the El Cheapo Harbor Freight Deluxe welding hood for a good while, and yeah, it works. You can see through it. This one here, the Lincoln Electric 3350 Viking welding hood, was recommended by a bunch of professional welders as a good, solid welding helmet, okay? Once I went from the cheaper welding hoods to this one here, the difference was night and day. If you cannot see your weld, you're not going to be able to do a good weld. You've got to be able to see it. In order to see it, you got to get your eyes up in there close, and you've got to protect your eyes. When you're arc welding, which is what this machine does, that arc is incredibly bright, ultraviolet light. It can harm your eyes. You've got to protect your eyes from the ultraviolet rays and the intense light that it puts out. So protect your eyes with the best welding hood you can get. Now I'm going to leave links down below for the welder, for all the goodies I'm fixing to go over here. Okay, so we're going to protect our eyes with a quality hood. You want to protect your eyes as well, another step further, safety glasses, okay? Yep, you're going to be a nerd with safety glasses. Why? A spark from your welding can bounce up, go under your hood, and bounce back against your face. And if your eyes aren't covered, you can get a hot hunk of steel in your eyes. These safety glasses here, and the ones I recommend, have a side shield on them, have little shield on the bottom that fits under the eyes, and extra shield here at the top that fits above the eyes. That way your eyes are covered. I'll leave a link down below for that. Check into it. Now, another important thing that you do when you get your welder is RTFM. Read the freaking manual. It's going to give you some safety tips about operating the machine. It's going to give you some setup information and what you need to know in order to correctly operate the machine here. Now I'm going to go over operation of the machine, but the manual is important, okay? So some of the other things you're going to need right off the bat is going to be some welding rods. I recommend 60-13 welding rods. Okay, I recommend you go with 1/8 inch for your thicker metals like 3/16 and up, and 3/32 inch welding rods for anything smaller than 3/16. Okay, you're going to want to run the 1/8 inch welding rods at about 100 amps to 130 amps thereabouts, and the 3/32 inch welding rods about 70 to 90 amps seems to be about the sweet spot for it. You're going to want to use a angle grinder. So get you one of them. I recommend a 110 volt angle grinder, and I recommend a good wire wheel. Now make sure your wire wheel is rated for the speed. I think it's like 13,000 RPM on most angle grinders here, and you don't want this thing here just exploding on you and sending shrapnel everywhere. These are very powerful and they can be very evil. Leave your guard on your angle grinder. You don't have to take it off, and be sure and use your handle. If these things here were to explode, or a defective cutting disc or flap disc explode on you, this thing can get knocked out of your hand. Ask me how I know, okay? So you don't want to be counting your fingers or be getting something pulled out of your innards by a surgeon. Now, in addition to a 110 volt angle grinder, I recommend you also get you a battery powered angle grinder. That way when you're welding, you may need to do some cutting and do some cleaning up here. This battery powered one, I have my cutting disc on it here. This is a diamond tipped cutting disc. This is great. It lasts, I don't know, about 100 or so of the little thinner ceramic cutting discs. And like I said, you want to have more than one. And so battery powered is good as well. I recommend you get you some of these guys right here. Okay, this is a flap disc that's used for grinding down metal. It's used for cleaning the metal, get you a good shiny surface, get the mill scale off. That way when you're welding and you really want to get a good weld, you want to clean up your weld, okay? So these flap discs are great for that. Every welder sold nowadays comes with one of these, I call them toy chipping hammers. You want a little chipping hammer to knock off the flux after you weld here, and both of these processes, the flux core and the stick welding, leaves a flux coating on the weld. So you're going to want a chipping hammer and a wire brush, and they give you this little thing here. Don't throw it away, because you may want to use it if you can't find the good stuff, okay? The good stuff that you're going to want to get is you're going to want a decent little chipping hammer. They don't cost that much. You can make your own. That'd make a great little project to get started. And then get you a good old school wire brush for cleaning up your welds. Another little goodie you're going to want is a torch holder with a good magnetic base on it. You've got your machine turned on, the electrode is energized. You don't want to be setting it on your table and sending up sparks when you don't want it. So a little safety thing is going to be the holder. Now make sure, remember when I talked about safety, this was energized if your machine is turned on. So if you go to reach something and you complete the circuit between your table that has a working clamp on it and your body touches that, you can get shocked. So I recommend getting the habit, taking your rod out of your electrode holder. As well, it will hold your flux core torch. I welded a little bitty tube onto my torch holder to hold my whelpers. That way they're always within reach. Okay, so these are whelpers. I suggest you get you some of these here. Let's start at this end here. These here have the tapered nose on it, and that is good for removing the flux and gunk that gets inside your nozzle. You can push this in there, turn it, it'll break all of that stuff loose. You've got this little hole here, and that's good for removing the contact tip inside of the nozzle. You've got the cutters. Now the cutters, if you notice, you've got a little hole recessed in here, and what that does, that allows you to push the recessed area against the nozzle, clip it, and you've got the correct amount of stick out on your nozzle, and you're ready to do some welding. You've also got this opening here, which is great for removing the nozzle. If your nozzle's hot, you can get that off of it. So it's a good investment. Okay, so now that we've gone over the basics of the machine, the equipment you need, I'll leave links down below for the machine and all that good stuff there. Let's go on to the intro of stick welding and flux welding. We got the links right there. I want to thank each and every one of you for watching. Give me a thumbs up if you like my video. There's a subscribe button down there. Take care.